All right, so for the kind of algebraic bit of this, so I've created some variables. W I'm defining as the width of one corral in yards. L I'm defining as the length of one corral in yards. And A I'm defining as the total area of the combined corrals in square yards. So I know that if I have length, 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 and width, 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 that I must have 4W plus 6L equals 16, because I know I have total 16 yards of fencing. And I know that since these are all equal, since I wanted my corrals to be equal, I know that if I take W times L times 3, that's going to give me the area. Remember, for a rectangle, if I take the length times the width, I get the area. Okay, so now I have these two equations, and I want to figure out what the maximum area is. And we talked about before how I can replace this. I can rearrange this as if I have 6L, and then if I subtract 4W from both sides, right, that gives me that. And then if I divide, then I get 16 minus 4W over 6. And now this L I can take and I can put in for here. So since these are equivalent, I'll replace them. So I get A equals 3 times W, then times 16 minus 4W over 6. And I can distribute. And I know that my area is equal to, I'm going to go ahead and put this part first. So I have negative 12W squared. That's over 6. And then plus 3W times 16. So 3 times 16, that's 8. Looks like 48. So 48W over 6. Now, of course, I should have been a little smarter with myself, and I could have said 3 divided by 6 is 1/2 first. So I know that that's going to become 8. So I have negative 2W squared plus 8W. So if I wanted, if I was going to graph this, right, I know some limits, right? I know that my W is not going to go past 0. So that's kind of a hard endpoint of my domain. And then, of course, if I had a width of 4, and 4 of those would be 16. So that's another situation where I would have that. And I can kind of do the same situation here. If I factor, I can pull out say I pull out a negative 2W. So I get W minus 4. So I know at 0 and at 4, I have zeros. So a few things to note. I know that parabolas are symmetric, so I can already tell that I'm going to get 2 for the x value of my vertex. But let's go ahead and do this algebraically. So I'm going to start with this form, and I'm going to complete the square. So let me go ahead and do that. The first thing I'm going to do is I'm going to factor out, I'm just going to pull out my leading coefficient, which is my negative 2. So when I do that, then I have this, and then I have the minus 4W. Now I'm going to complete the square. I want to get it into a form where I want to eventually have something like this form where I have a times x minus h quantity squared plus k. I want to be in that form, and then that's going to show me where my vertex is. hk is going to be my vertex. So my vertex at hk. Okay. So I'm going to complete the square by finding a value to put in. So if I think of this as I have a w squared, right? It's w by w, so that makes a w squared. Then I'm going to put pieces on each side of negative 2w. So I broke this negative 4w in half. So I have a negative 2 here and a negative 2 here. So negative 2 times w makes negative 2w, and negative 2 times w makes negative 2w for an area. So I want to complete the square. I want to put this bit in. Well, that's negative 2 times negative 2, so positive 4. So that's the value that's going to be placed in here. I'm just going to rewrite that a little farther over so that we have space. So dot, dot, dot. So negative 2 so I'm going to add 4. Now the problem is I just added a value to what wasn't there before. And in fact, since this 4 is being multiplied by negative 2, I actually subtracted 8 from the whole equation. So I need to tack on another 8 to balance that out. So I added my 8 back, so now that I've kind of redone that. So now notice that I have w minus 2 squared. So that's negative 2 times w minus 2 quantity squared and my plus 8. And so now I'm in my vertex form. So I have a vertex at 2, 8. So come up here at 2 and up here at 8. I have a vertex, and then I know that it's a parabola that goes down like that. So in terms of my answering my questions, my first question was, what are the dimensions of one corral that would give me the maximum total area? So the dimensions would be, one corral would be L by W. So I know that W was 2. So my W is 2 yards. So then I need to find my L. I can do that by putting W into my original equation here, or I can put it here. So I have 16 minus 4 times 2 all over 6. 16 minus 4 times 2 is 8, so 16 minus 8 is 8, so 8/6, or we can reduce that to 4/3. So my length was 4/3 yards. So some people wrote 4 yards, and they forgot to answer the question properly. 4 yards would be the entire length of the 3 together. Okay. So these are my dimensions. Then it also asks what the total area is. Well, the area is just based on, this is my output, so that's my output there. So I have 8, and remember I was in square yards. So I have 8 square yards. And that's all the information